I'm very glad to and very honored to be here at NIT Trichy. How many of you are NIT Trichy's group? Okay. And what are the other groups?
I'm from University of Madras.
Madras? Okay.
GIAN. I'm studying GIAN informatics.
Okay, okay.
I'm from Gaja College of Engineering, Madurai.
Madurai?
Studying BE final year.
Okay. Civil engineering.
From Chennai, Wells University. Studying BTech biotechnology.
Okay, okay. Biotechnology. Okay. So that's it, right? The rest are all NIT students. Okay, good. And I know that 2 more girls are coming. Yeah. Okay. So I'm glad that some biotech people are joining us because a lot of people get not confused, but so forensic is a big topic today. Okay, and many of you probably are aware of the forensics for computer science. You know, data analytics, trying to find problems in a computer software or through the internet. Okay, all these are related in a way because they are all forensics. In other words, forensic in a very, very narrow sense, it is an area of study that doing the inverse engineering. We're trying to find the problem solving, okay, and rather than design, okay. But the significant part about forensic engineering is that in the U.S. and other parts of the Western world, okay, forensic engineering is very specific towards civil and mechanical engineering. Okay, in other words, we're dealing with the physical infrastructure. Okay, any problem related to that particular type of physical design is our concern. But the methodology will be the same. Okay, whether it's for biomedics, informatics, or for any kind of medical field, the investigation is the same. Okay, so forensic engineering, as we discussed, is a very new area in civil engineering. However, if you think about what we have seen, you know, throughout history, okay, whatever human beings do, there's always a problem. Okay, there's always a failure of some kind. Okay, as long as it's something that's being engineered, the chance of you doing something wrong is very highly likely. Okay, and so forensic engineering, the history is probably as old as engineering design, even before engineering exists. Okay, so we will be talking a little bit about, you know, when does the guidelines of controlling what we do as engineers come about. Okay, so the significance about forensic engineering, of course, has to do with fault finding. Okay, and what fault finding is usually related is the legal system. In other words, if there's no law, there's no fault, right? I build a building and it collapsed. As long as I don't kill anybody, who cares, right? But because there are regulations and guidelines in designing safe, making sure that our design is safe, okay, then it makes us liable for what you design and build. Okay, and that's why there is a forensic engineering. In other words, if there is no law, no legal system, there is no need for forensic engineering. Okay, so this is a very unique profession within the domain of engineering that is as old as engineering itself, and yet it doesn't fall into the category of other engineering components unless there is a law that regulates. Okay, and among all the engineering professions, civil engineering is the most regulated profession. Okay, so we have very stringent guidelines on how you design a building, whether it's a steel, concrete, wood. Okay, how do you perform geotech design, the foundations and so forth. Okay, and so because we have this rigorously rigid design guidelines, civil engineers have advanced professional level of requirement that we have to do everything safely. Okay, and so in the Western societies, especially predominant in the US, we have professional engineer license. Okay, so unless you pass the exam, you cannot do design. Okay, and hence the professional licensing is the first requirement for forensics practice. Okay, if you don't have an engineering license, you by law you can't even practice forensic because you cannot do investigation. Okay, and so those are the kind of things that we will be covered within this 2-week span. Okay, and forensic investigation is, so in a nutshell, it is about practicing engineering. Okay, analysis, design, investigation, and so forth. But on the other spectrum, it is also highly related to the legal profession. Okay, so one of the class that we will have will be actually, learning about the language of the forensics. Okay, and surprisingly, and not surprisingly, in the legal profession, we use a lot of Latin language. Okay, so we'll be going through, I know that you probably like me, we don't have the Latin training background. I have very, very short Latin lessons, but but you'll be surprised by how much Latin words we use in our daily life. Okay, so we'll be going through that. And then regarding the engineering practice, so it becomes extremely important that we have the experience of doing some kind of investigation. Okay, so this class was designed to have a component of investigation. Okay, so we will have a class project doing that. And also at the same time, I wanted to introduce some new tools that we use in forensic investigation. Okay, and in this particular aspect, we will be doing some homeworks on using LiDAR point cloud, okay, using laser scan for investigation. Okay, and my student sitting in the way back, Navadit Shamugan, he will be giving a lecture on LiDAR point cloud analysis, and he will give us the homework that we will be doing the analysis on. He's doing his PhD in engineering at a multidisciplinary engineering PhD degree at my institution, okay, in Charlotte. Okay, so this is in a nutshell what the class will be. And so it is a class that carry out by a very long tradition. Okay, so for those of you who are at NIT or who are not at NIT, you may not know that NIT has a very long history through the collaboration between me and several faculties at NIT Trichy, that we have actually been teaching forensic and field investigation for many years. Okay, so the first time when we get interaction was actually in 2007. Okay, so more than 10 years now. Okay, 12 years to be specific. And this is me without a lot of gray hair. Okay, so at that time I was an assistant professor, so still young. And many of the faculties that you just met, Professor Moses and so forth, are here. Okay, so this place to me is almost like home. Okay, I know the faculties here as well as my faculties back home. Okay, and this is Dr. Shen, who very unfortunately were not able to be part of this class. So I will be delivering 2 lectures on his behalf, okay, on this topic. Okay, so in the past, he and I used to co-teach this class, equal even Stephen, but because he's not available now, so I'll be teaching. But rest assured, okay, that forensic is not an area that is exclusively in the Western society. Okay, so even though I'm coming from the West to teach here, but through Dr. Shen, I realized that forensic problems are pervasive in India, in many areas. Okay, in fact, I will tell you a little bit of history, especially between India and my organization. Okay, so despite as a professor in a university in the U.S., I'm also a member of the American Society of Civil Engineers. Okay, so that is the largest group of civil engineering, practicing civil engineering organization in the U.S. Okay, in fact, it's international. Okay, so there is multiple local chapters of ASC in India as well. Okay, but I will describe a little bit of that. But you can see that this class that we're teaching is not new. We have been doing this at NITT for many years now. Okay, and this is a brief class objective as I described in the beginning. Okay, so we wanted to introduce to you about forensic engineering practice. Okay, and as I start describing some of Dr. Shen's project, okay, you will realize that yes, you see similar problems in India. Okay, even though the professors here don't call it forensic engineering or failure analysis, they're doing some kind of consulting related to that topic. Okay, and we will talk a little bit about some of the fundamental failure analysis techniques. Okay, so it is slightly different from your typical engineering. I like to liken the forensic engineering as scientific investigation. Okay, so we are all students of science. Okay, but we by training is the application of science. So we are doing applied science. Okay, but forensic engineering is probably more close to actual science than our typical applied science, in the sense that forensic requires that you be able to systematically investigate certain things. Okay, science is a very pessimistic topic. Okay, so a lot of people learning science thinking, oh, I'm going to be a great scientist. I wanted to invent something. Okay, by the time that you wanted to invent something, you are no longer a scientist. Okay, you are an engineer. Okay, so Einstein has once made a clear distinction between engineering and science. So science is the investigation of things that exist. Engineering is the investigation of things that doesn't exist. In other words, when you design a building, the building doesn't exist. Okay, that's why engineering is very, very different and more challenging than science. But science is very basic. Okay, science is defined as the elimination of all possibilities. Okay, so anybody think that by studying science I can improve human lives? You're wrong. Okay, you are trying to understand how life is, but you are not improving life by any measure. The moment that you leap over trying to improve life, you become an engineer, if that makes sense. Okay, and so forensic investigation is very, very core based on scientific investigation. So you have to be able to have the capability to look at a problem and then start taking out all the unlikely causes. Okay, so whatever remaining, that would be the most probable cause. Okay, and please pay attention to the way that I use my language, because we have to, as a forensic expert, you have to stand in court. Okay, and the lawyer's role, so your closest friend and enemy is the lawyers. Okay, the lawyers will ask you very critical questions, either support your cause or against your cause. Okay, they are not trained engineers, so you have to be able to speak language that are down to earth and people can understand, who are not engineers can understand. Okay, but at the same time you have to watch out for legal traps. Okay, so the lawyers will ask you critical questions like, are you certain this, are you 100% certain this is the reason why this building collapsed? Okay, then you have to explain to them, well, based on my investigation, I am 100% certain this is the most probable. Okay, then they will come back and ask you, what do you mean by 100%? Can you give me how you calculate this 100%? You know, so you quickly realize that the biggest challenge in forensic practice is not the investigation. A lot of time is to convince them that whatever you do is done professionally, because they want to disqualify you. Okay, this spring I was in a court case, and we are defending 5 homes that were damaged by blasting. Okay, so they are building a dam, and they have to blast part of the mountain to create more space for the dam, and they are using that rock that was blasted to build the dam, okay? And so, as a result, the blasting caused a lot of homes damaged, okay? So I'm defending for the homes, and the lawyers will ask me very critical questions, okay? I don't know how many of you have the knowledge about blasting in mining, okay? It is a very narrow area, and there's only one person, his name is Dowding, okay, that has published one book and the field reports on blasting effects on buildings, okay? And so I am a much younger gentleman than Dowding. He's, probably in his 80s now. And he's no longer, he's retired. And so when I present my work, they will question me from his book, like, on which book did you find that Dowding actually say that this is the reason for this kind of problem? Okay, did you prove that the house has only cracked more than 0.3 millimeters? They ask those questions, and I have to tell them, well, no, I cannot prove that, okay, because by the time the plaintiff come to me, plaintiff are the people that sues. The other side is the defendant, right? So the plaintiff, when they come to me, the case is already closed for 2 years. In other words, they stop blasting for 2 years. So whatever crack that I found on those homes, okay, I have to use some other means to prove that it has relation to the blasting, okay? And I have to do it scientifically. So I have to explain to them, yes, if you invite Dowding to defend against me, he has more seniority, okay? I have less. But our scientific investigation approach should be the same, okay? And our conclusion may not be the same, and then you have to present to them why. Okay, so I will, throughout this 2 weeks lecture, describe this case study, and then show you some of the methods that I use in practice. Okay, and so this gives you a sense of the challenge of this. But we will also introduce, like I was pointing out, LiDAR technique. Okay, so when I started doing LiDAR investigations since 2007. LiDAR was not very popular. Okay, at that time nobody used LiDAR, but now, at least in the U.S., LiDAR is used every day. Okay, when they have a new home built, people will use laser scan. That keeps an electronic document of your building. Okay, so now, if you have a problem with your home, you can use LiDAR scan again, and then compare the before and after image of your home, okay, and then you can find out how much was the damage and so forth. So those are coming technology that I believe maybe within 10 years it will be practiced in India, okay, because Indians are very smart, okay. Whatever that we invented over there, within 10 years you catch up, you'll be doing the same thing, okay. So many of you will, in your very immediate career, you will be seeing LiDAR scans. So I think it is very timely for us to introduce those kind of new stuff to you, okay? And of course, I can't bring the laser here, but we have the data that we can share, and also we will do the analysis together, okay? And so this is I'm reiterating myself, okay? So forensic engineering is a very special branch, okay? Not many of us practice, okay? In fact, the group that I belong to, we have less than 100 members, okay? Probably less than 70 members, okay? But the practice actually is more popular, okay? And one of the mission of my group, the Forensic Council, is actually promote forensic engineering so that other practicing engineers who do forensics would understand that, hey, there is a group of people who, one, disseminate data. In other words, we publish data, okay? And two, we disseminate the practice. In other words, we make our work known and then make more people aware that forensic engineering is a real thing, and people need to be aware that there are so many things you need to learn other than just being a civil engineer, Okay, and then the last thing is that we have be able to and one of the things we will talk about is what is failure. Okay, so failure analysis has to do with something that was not designed properly. Okay, it failed to serve its function. Okay, so those are the critical elements that we will be looking at together. Okay. So let's talk about failure. So there are many aspects of failures. Okay, it can be a building that was designed poorly, or it can be something that had a natural disaster. Okay, so this is the Hurricane Ivan, and we did an investigation of this entire building, and you can see it has many kinds of problems. Okay, you can see all these are wood panel block off. Okay, and even this is the original panel. This is the no, it's still the original, but they protect it. Okay, and in fact, this is a very good time that one of the lectures that I will be discussing is disasters that are beyond typical engineering design. Okay, and in fact, I will talk about, since this is a practice. Okay, I'll talk a little bit about the industry. Okay, so disaster industry is $1 trillion business a year in the world. Okay, so forensic engineering is actually a profession that is blowing up. Okay, many people are involved now because of failures, and many of these failures are going beyond engineering design, and I'll describe a little bit about those. Okay, based on my own expertise. In fact, some of our students here are, we did the investigation together, so I'll talk about that as well. But you can see, failures of these lentils, and you can see the sand on the bottom. So in the U.S., your client is most likely be two kind of people whenever you have this kind of issue. One is the plaintiff is usually the insurance company. Okay, and the insurance company, every house in the U.S. are insured in some way. Okay, so once your house has a problem, first thing you do is call the insurance company, and they will send somebody like myself and do the investigation. And on the other side of the coin is the defendant. Okay, so insurance company trying to preserve their money, right? So they will hire people who most likely will agree with their investigation, which is, yeah, your house is old. Okay, this is bound to happen. So, your house was built in 1920s. It's based on 1920 code. Of course, your house collapsed. Okay, it's not up to date. They will give you that kind of excuse. Then the defendant will hire a bunch of people again, like me, that will argue that, yes, this house was built in 1920, but it was so strong it survived several hurricanes. But now this one, because of this particular damage, the house was damaged. Okay, and so you quickly realize that even though we are all civil engineers trained maybe by the same teacher, but we may come to different conclusions of a particular case. Okay, so but while you may argue, well, this is not exact science, right? That's what makes it interesting. Okay, and so your training and your way of investigation become extremely important. Okay, and again, we can see all kinds of damages on this structure. So this one building alone, okay, it will be a multi-million-dollar. I don't know how many lakhs that or crores that will represent. Okay, it's a lot of money. Okay, so a lot of people's lives and livelihood sometimes is dependent on your investigation. Okay, so it becomes really critical to be able to investigate. And many times you will see strange things. Okay, so for example, this very high-rise building, and then this one particular column, has failed. Okay, so as a civil engineer, your job is to come and say, okay, this was damaged by waves, or is this damaged by something else? Okay, because by the time that you are hired to do this work, usually it's 2, 3, 4, 5, 6 months after. Okay, so when you come, many things has changed. Okay, even if they have this picture that has the beam standing there, you will not be able to see what was the cause. Okay, so as an investigator, it becomes very important for you to see details. Okay, you have to be able to quantify very, very narrow. One of the arguments in this case is that, hey, there was a big car here, and then the wave pushed the car and the car hits the beam, and that's what caused the failure. Is that true? How can we prove that is the case? Okay, so those are the things that forensics engineers do. Okay, and there are some really, really amazing failure investigations, like the Kobe earthquake. Okay, so in this case, the entire building collapsed. Okay, you almost don't have to argue why. You know, we know it's the earthquake, right? But still, insurance company will work very, very hard to argue the case. Okay, so many times the argument will come here into this case is that is your building foundation liquefied. Okay, and the reason is because in many countries, earthquake design and liquefaction of the soil are two separate issues. Okay, and so this becomes this kind of incidents becomes a very long battle for the engineers. Okay, you have to prove a lot of things. You do a lot of drillings. You get the soils out, and then you have to do a lot of triaxial tests to prove that the soil tests show that the soil has either liquefied or not liquefied. Okay, yeah, you have to do a lot of dynamic analysis as well to prove that the shaking force was able to strongly, cause the building to collapse. So a lot of those investigations has to be done. Okay, after Trichy, I'm going to China, and I'll be taking 8 of my students from the U.S. to investigate the 2008 Sichuan earthquake in China. Okay, so this is one of the significant earthquakes in 2008, and 80,000 people died. Many of them were buried alive. Okay, and so our students are going there and collect the historical data from that time. Okay, and then trying to do some resilience assessment. Okay, so engineering resilience is about after a major disaster, how quickly people can recover. Okay, so now it's after 11 years, we're going back there and trying to study the literature published on this work, and then see how quickly people have recovered from this disaster. But you can see that some of the major disasters can actually change the course of a river. Okay, and so in this kind of incidents, your investigation may be years after the incident because you cannot get to the point, the access to the location. Okay. Yeah, this is more picture of the Sichuan earthquake. So your investigation goes from partial damage of a structure, minor damage of a structure, to completely collapse of an entire structure. Okay, so the extent of forensic investigation can go from a very wide range. Okay, and this is one of the investigations I did in early on of my career, and this is a very unique case. Okay, so at that time I lived in a city called Birmingham. Okay, Birmingham, Alabama, in the U.S. And it is the temperature is very much like here. It is the deep south of America, so the weather is very warm. Okay, and what's happening here is actually the city is growing. So many people has moved in, and new homes are being built. Okay, it has a lot of hills. Okay, so compared to Trichy is very flat. Birmingham has a lot of mountain, not mountain, but they are small hills. Okay, more like Madurai. Okay, but the problem with Birmingham is when people start building a lot of homes. Okay, it actually changed the groundwater level. Okay, so when you have poor compaction of a home, okay, suddenly the groundwater drop. Then you start having source collapse, okay? And so we see a lot of those homes having this kind of slope failures or soil collapse compounded failures. And we have to go and do investigation. And then it was, at that time, we see multiple homes. Then we start realizing that, hey, the problem is much bigger than just, poor compaction of the ground, okay? The groundwater was actually fluctuated because of the draining. People had to build new home, they drain the groundwater and they change the water path, okay? And so you result in multiple homes failure, okay? So it quickly becomes a very big lawsuit against multiple members, okay? And some of my investigations related to coal mining, okay? So in coal mine countries, you see a lot of homes that collapse suddenly, even though the mines are closed, okay? And so in Tamil Nadu, I don't think we have too many coal mines. Yeah, there's one between here and Chennai, right? But not a significant area. But in the U.S., we have a lot of coal mine, okay? And the only way that you can prove that this coal, so this is a subsidence. You may not be able to see, but this piece of land suddenly dropped. Okay, so you have a very, very straight edge. That tells you that this was not something that was not man-made. This is doesn't happen naturally. Okay, and so what we do is we take the old mine maps. These maps were made in the 1960s. Okay, even before I was born. Okay, and so there is no GPS data. We have to take this map and then make sure that using Google Earth and similar tools to make sure that this area is indeed on top of this home, okay? And so we learn something in the forensic language, okay? So even though you don't have the means to physically prove that this subsidence has something to do with the coal mine, because the coal mine is 1,000 feet, 700 meters deep, you can't prove that this is directly related. But because this home was on top of the coal mine, okay, you can, based on the cost of law, to just judge the coal mining company is responsible for this. Okay, this is what we call the class action lawsuit. Okay, and so many of those cases are being investigated in the past. And so those are big money, okay? So the mining company lawyers are fighting very, very fierce against any lawsuit against them, because if you can prove one home is damaged by the coal mine, there are hundreds of homes. So suddenly it becomes they have to pay $1 million. That becomes huge money, okay? And so this is a critical kind of case, and of course many times your investigations, the failure is probably more related to construction. Okay, so this is a case where they are building a caisson. Okay, and then when they were digging, and then doing rock blasting, suddenly groundwater rushed in, and then everything collapsed. Okay, and so now they stopped the work, and now they want to investigate who is at fault. Okay, so you can see this bulldozer was literally stuck in the mud. Okay, they can't take it out anymore. Okay, so who is at fault? Okay, so you are being invited to do investigation, so you have to go in there and look at what's the problem, and any technique that you can use to prove one way or the other becomes useful. Okay, so this is what the forensics people do. Okay, and this is the same picture, and this picture you can see the steel piles being driven into the rock. Okay, but notice that there's something that came out from behind. Okay, so now the question is, what is this material? Okay, and this specific lawsuit was actually the construction company against the blasting company. Okay, so the construction company claimed the blast company did a very poor job in blasting this area, and as a result, some of the rocks become incompetent, become weak, and so when they drive, and then the rocks fall apart. But from this picture, you can see that this is something from behind the rock. Okay, and so our conclusion is this is more geology than blasting. Okay, so what happened in this part of the United States? We have a lot of we call the pinnacles. So in other words, in this area, the rocks are actually, if you take out all the soil, the rocks are like little mushrooms on the ground. Okay, and so when they do blasting, they blast out the rocks. It's okay, but when you are doing drilling and then you put the piles, suddenly behind the piles you have residual soil that you should have excavated completely, and you did not. And as a result, when the groundwater starts to flood the area, you have this material suddenly washed out. Okay, and then the piles become weak, and then you get more problem. Okay, and the groundwater in this case happens naturally because this project is right next to a river. Okay, so we know that they have very, very soft soil. Okay, but the piles are supposed to be able to protect the area from any groundwater seeping. Okay, so these are the cases. Okay, and we will be talking about some famous cases like the 1981 Higher Regency walkway collapse. Okay, so if you look at this picture, there is actually another walkway right here, similar to this one. Okay, and this is one of those very famous case studies because in 1981, American law does not qualify engineers as liable for this kind of problem. Okay, but this fell because of design failure. Okay, in fact, when I present this case, we'll have more discussion on, what exactly happened there. Okay, and there's a 2007 I-35 bridge collapse. Okay, so this bridge fell in what we call the perfect storm. Okay, so and this bridge collapse becomes a strong litigation. Why? Because many people claim that the bridge was having major issues. But the fact is, when the bridge collapsed, they are actually repairing the bridge. Okay, and so what happened in this case is the bridge has already, the State Department of Transportation has already claimed that they already do the inspection. They know the bridge is not safe. Okay, they have contracted, construction group has been going out there, and it was the perfect storm because this is a major highway bridge. Okay, and it happened at noon when people are going to lunch. Okay, and because they block off half of the bridge, only half of the bridge had traffic, and cars are parked completely on top of the bridge. Okay, and then on this side of the bridge, they have many bags of concrete, steel beams, all stored on top of the bridge. So you have the maximum loading on the bridge, static loading. And then suddenly the bridge, it's a truss bridge, suddenly some of the connections fell, and then the bridge collapsed. Okay, so that's what we call the perfect storm scenario. Okay, and after that, every major incident like those two, I will explain to you the implications to engineering practice. Okay, so after these two incidents, there's a lot of debate in the engineering profession, how we can do our job in a safer manner. Okay, and so forensic engineering is not just about doing a case. Okay, it's actually a practice, and we encourage. In fact, this is one of the early mission that CN and I have when we start to collaborate. Is that how can we promote forensic engineering practice in India? Okay, so that many people like you, we can put our minds together and then we can enforce the practice, okay, and then hopefully we can be a much safer profession, okay. And then there are some that are man-made, okay. So this is the 1993 World Trade Center bombing, okay. The building fell. We don't know if was actually the way that the tourist has designed for, okay, but the buildings collapsed, okay. In fact, this building collapse becomes a very, very significant as far as technology for forensic investigation, okay, because many people who saw what happened died, okay. So there is no data for us to be able to investigate what actually happened, okay. Each of this building is a $1.5 billion lawsuit, okay. So the insurance company for those two buildings and the owner of this company for these two buildings are still fighting even today, okay. And we hire some of the best forensic companies in the U.S. to develop some really advanced techniques. So what they have done is they were able to take people's cell phone images, the video they take, and then use a computer algorithm to demonstrate what happened when the airplane hits the building, okay. Even so, even with all this advanced technology, I still receive newsletters from a group of architects, okay. They believe the building was not down because of fire. They believe some other, theories, okay. So even among professionals, people are not agreeing how the buildings collapsed, okay. The question is, there's two buildings, right? So the first building down and then the second building come down, okay. They did not come down simultaneous, okay. So the question is, did the first building come down, create enough shock to bring the second building down? Okay, so there is even a professor from MIT, a physics professor, wrote a long article published online to claim his theory of what happened. Okay, but this is what makes forensic engineering a very interesting profession. Okay, because you have to question constantly. Some of the old cases that I did in investigation, I still question. Am I right? Is my conclusion the only certain conclusion? You're constantly thinking about those problems. Okay, and failure analysis. Okay, so failure analysis, even though it sounds new to civil engineers, actually I had dinner with Professor Babu from IIS, Bangalore. He was here the night I arrived, and so we had dinner together. He also stayed at a guest house. And he's a geotech engineer. He's heavily promoting geotech forensics in India, okay? And I admire his spirit. But to the geotech people, every case study is a forensic case, because there are so much unknown in every failure. And so I think he's right. But the important thing is failure analysis is, from a system engineering perspective, it's actually a very well established science. Okay, so if we civil engineers can learn to look at failure from a system perspective, it will help us to understand more and be able to do our job much more systematic in many ways. Okay, so this is a very brief outline. You have to understand failure. Okay, so you do the investigation, you do the analysis, you argue about the case in your own minds or with your colleagues, and then you have to be able to learn from the failure. Okay, what is the higher level modeling of the problem? Okay, can we use a very simple algorithm to describe how a system failed? Okay, so that people can understand our logic. Okay, and then include in that meta modeling, there is a fault tree analysis, which I'll describe briefly, and then there's the window of opportunity analysis. All these are terminology used by system engineers. Okay, and then how do we recover from the failures? Okay, there is a psychology of failure. Okay, so in other words, as a civil engineer, we should constantly be mindful that our design algorithm, our codes are not necessarily perfect. Okay, so with an understanding of anticipating likely failures will help you to become a better engineer. Okay, and I will talk in one particular case why that is so. Okay, and then the lessons on ethics. So many of the failures are really due to some of us not practicing diligence. Okay, especially contractors or the construction party. Okay, they're trying to cut corners, save materials, and as a result, there's a failure. Okay, so those are critical questions that we have to be able to. And then there is a possibility of managing failure. Okay, if you have construction management background, okay, so construction management is a very useful tool to help manage or minimize the chance of failures. Okay, and then finally, we have to educate failure, just like what I'm doing today. Okay, where our sincere hope is many of you who graduated and go out practice for a few years, you will start to do the same thing. You start teach failure analysis. Okay, and so in that aspect, we will be discussing the forensic engineering curriculum. Okay, forensic engineering degree and so forth. Okay, MIT in that aspect is very forefront than many Indian institutes in teaching forensic engineering. Okay, and my institution also has a very long history of teaching forensic engineering class. Okay, one of the challenge that you guys will see more and more than we do, or at least me. Dr. Kartik is still younger than me, so you know, my level, most of my problem we see are, you know, one building collapse, two building collapse. The case that I was showing you about the groundwater fluctuation, that is more of a systemic level. Okay, the entire project level failure. Okay, and you will see more and more of those coming. Okay, why? First of all, the projects that you will be seeing are going to be mega projects, especially the Chinese are coming. If they start building high-speed railroads, you know, those are big projects. Okay, if you work in Chennai and involved in the metro design, all these are big projects than just build a 10-story building. Okay, so all of those kind of problems, you have multiple people involved of different disciplines. So the failure, the likelihood of failure becomes more multidimensional. Okay, so as a forensic engineer, you should be able to do beyond just structural analysis or geotech analysis. You need to understand people. Okay, you need to be able to find problems out of how people function. Okay, in a group. Okay, and that kind of higher level system problems are more and more today because we are getting more global. Okay, so the integration of engineering practice becomes across nation. Okay, one of my students worked for one of the largest power transmission structure in America. He's the head of the geotech, and he called me one day, and this is, I'm not joking, this is 2006. Okay, he called me and said, Dr. Chen, do you know I'm designing transmission towers in India? And he never been to India. You know, so somebody who's not here, and then yet he's doing design, you know, the stretch of his imagination and his professional capability becomes very, very large. Okay, and so if there's a problem happening here, you can point your finger all the way across to one American engineer. He's the problem, right? How do you get the money from him? That's the question. But systemic problems becomes a big issue, especially when we are in global. Okay, so right after the EU was formed, okay, one of the problems in 2012 is that the economy started to collapse. Okay, so if you remember in 2012, the Spain, Portugal are the nations that become bankrupt. Okay, and they demand more money. They want to borrow more money from EU. Okay, and so at that time, Italian, this guy also get into trouble. I think that was the last year for his term. Okay, and so you quickly realize that when you cross national boundaries like the EU organization, okay, it becomes difficult to manage business, okay? And that is why it should not be a surprise that today we have such an issue of Brexit, okay? Even at that time, the British people has already voiced they want to separate from the rest of the European country, okay? So you quickly realize that at the system level, failures goes beyond your traditional civil engineering training, okay? And the analysis of failures from a failure analysis is very complicated, okay? But most of the time, you go through a chain of reaction analysis, okay? So you have to use a time-dependent process to look at how failures happening. If we are all educated in this kind of analysis, it will help us tremendously as civil engineers, because in every civil engineering project, there are windows of failures, or windows that you can see a failure, okay? Because by the time that you start talking about wanting a project, for example, build a bridge between here to Tanzhou, okay? The project may start 2000, okay? By the time you do the preliminary design, consulting company, okay, the local government has to raise the money, right? So they go to daily ask for money or whatever they do, and then once the money comes, they're probably already 1 or 2 years behind, right? 2 years behind, that means many of your investigation, the geotech, the initial design has maybe invalid, okay? And then once the government has the money, they ask you to redo the design, okay? Many things change, okay? The local people start fighting, politics get involved, it will be another 2 years when you finally start designing your bridge, build your bridge. So within that 6-year span of many things could have happened wrong, or could cause later on something wrong, okay? So we'll be looking at some failure cases, okay? And there is another kind of system failures, and that is from our own problem, engineering problem, okay? So this is 2011, one of the high-speed train in China that failed, okay? This is the route from Shanghai to Beijing, the two largest cities in China, okay? At that time, from Shanghai to Beijing, you take the train, it takes 7 hours, okay? Running at 300 kilometers per hour, okay, at that time. So they want to reduce the speed, so they designed the train to run at 380 kilometers per hour. That would cut down the time to 4 hours. Well, the first time the train flies, it has a major accident, and many people die. So Chinese government is not the smartest government, no matter how much they think about themselves. So what do? They limit. From now on, no train will go beyond 350. Instead of solving what went wrong with this problem, they used government law to limit the high-speed train. Okay? Well, the reason why they don't go into technology is because this is not Chinese technology. Every high-speed train built in China is German technology. The German built the first line of high-speed train for the Chinese, and after that the Chinese just replicate on their own. So some of the technology, embedded technologies, they don't understand. Till today, they still don't understand. But instead of going and admit that they copy other people's technology, they just hide the problem. Okay, so the transportation minister was put in jail. I think he was shot. They claim that he had some kind of corruption, and then he was killed. But then they just limit. They have somebody blamed, and then they limit the highest speed they can ever achieve, and then forget about the technology. That is not the way that engineering should be practiced. We need to dig to the roots of the problem, understand how it is designed, okay? And that should be the way of engineering, okay? So even though sometimes politics involved, but we as engineers, I think, or I hope that you all have the guts to at least stand up and say, I want to learn everything that is inside, okay? And so what I just described is nothing new. Okay, so we have a famous professor in my state. He's not from my institution. His name is Henry Petroski. So you please write his name down. He wrote several books about engineering failures. Okay, he's famous for the study of engineering failures. Okay, and but he famously claimed that every 30 years there will be one famous bridge collapse. Okay, and he's pointing finger to all of us in the sense that there is a common, very pervasive, so it's not just the Chinese. Okay, every one of us has the habit of copy somebody else's design. Okay, and if you don't fully understand the design, you just copy. Eventually, it will be like taking an image and then recall on the computer. Eventually, the resolution disappears. It becomes very poor quality image. Why? Because every time you copy somebody else's work, if it's not the original work, you lost a lot of the fundamental theories. Okay, and as a result, one of us will screw up and build a bridge that will collapse. Okay, and in his book, he mentioned many case studies. Okay, and so this is Henry Petroski. These are just some of the books that he has written. Okay, to engineer is human, the pencil, success through failure. So we have invited him to speak at one of our profession, and he admit the reason he's successful in writing many books because his wife is an English teacher. So he has somebody that help him proofread his writings. But engineers are notorious of bad writings, right? Okay. But anyways, he famously claimed that every 30 years there will be a major bridge failure. Okay, and we see that in Tacoma Bridge. Okay, in fact, Tacoma Bridge, for many of you, you may be, educated going through that it was a resonance failed structure, right? There are a new study, I think was coming out 2-3 years ago. A Japanese actually found that was not the case. So even for me, I've been teaching that, that famous video of the collapse, that was not the cause for the failure. Okay, the failure was actually before the resonance. So the Japanese will prove that all of us were wrong. All the professors were teaching it wrong. Okay, but yeah. So by being quoting from Henry Petroski, we admit that even in some of our lectures, we're not necessarily teaching the right information because we again learn from somebody else too. Okay. Any questions so far? I know I'm babbling, but it's a very interesting, and it should be a passion, okay, for all of us about failures, okay, especially as civil engineers. And over the years coming to Tamil Nadu, I've learned a lot, okay. I've been to many of the temples, okay, and fascinated by some of those designs, pre-engineered designs, okay. They are before engineering is a profession, okay. But we are learning as we grow as a profession, okay. And only by sharing information with each other, and then knowing that we're not the know-it-all, okay. So we can learn from one another, and that is how our profession can become better and better, okay. One of our projects. Thank you. One of our projects, for our BTech student, is the last year's BTech student every year is to design how can we mine from meteorites, okay, asteroids, and the world will be very different as we evolve, and especially some of you BTech, when you graduate, you'll be doing something very different. Okay, automation is coming, so there is a big call for robotize construction management, construction process, 3D printing of concrete structures is coming. Steel structures has already been done. Okay, so there are so many things that are changing the fundamental practice of our profession. Okay, so like what Petroski was saying, okay, because of all these new technologies, failure will happen. Okay, and so learn from failures. It's the most important lesson for all engineers. Okay, and that's why we are here to promote forensic engineering and failure analysis. Okay, I mentioned some of the tools. Okay, so these are just few of those. The essential idea, and all of this, there are software behind that supports all these theories. So window of opportunity model is a time series analysis method. Okay, so when you look at the history of a building's lifetime, okay, there are so many possible opportunities that you can essentially create a future failure. Okay, from the design to the construction to the operation of a structure. Okay, so if you can create such an architect of the history of a structure or a design, okay, you can go through a project and you can identify where that failure may have already been embedded in your design or in your project and cause a future failure. Okay, and those are very important because then you know how to correct the problem properly. Okay, and those are critical issues. And as I mentioned, system failure prevention is very important at the system level because the society is becoming much more complicated today. Okay, and even the interaction about people becomes more complicated. Okay, so we need to be able to manage, we need to enhance its performance. Okay, and then stability, sustainability, and security are all critical issues that we are dealing with today. Okay, and these are some of the changes. Okay, the technology advancement, rapid, robust, institutional changes is a lot slower. Okay, so you can actually take every of those high-level components and then recognize its implementation. Okay, and so throughout my several lectures, I will show you from different perspectives. Okay, how forensics can actually benefit some of those other disciplines of studies. Okay. And but the important thing is to recognize that the project, every time we talk about a project, is no longer just a simple owner-client relationship. Okay, it goes beyond. It goes to government. It goes to insurance. It goes to the people who actually live in a home and so forth. Okay, this is not something new, right? Everybody should have an understanding. Okay, and also recognize the players in this. Okay, so there are many players that are involved, and actually this is a very important part. Okay, so one of the lecture I will be dedicating to is the industry. Okay, so when I mentioned that forensic today is a $1 trillion industry, okay, the people who come up with the money to fit into this industry is not just owners. Okay, so we have found that there are many civil engineers, maybe one of you one day will be, are actually working for NGOs. Okay, groups that are non-government yet dedicated to humanity efforts. Okay, and so those are the people that actually come up with a lot of money. Every time the city I live in is called Charlotte, okay, and one of the group within my city is the largest NGO group that supports disaster. Okay, they are called the Samaritan's Purse. I don't know if you heard of Samaritan Purse. They are the largest group of people who donate money and material. So they actually own big airplanes that are cargo airplanes that if there's a disaster in Haiti or somewhere in the world, they will fly materials to those countries. Okay. I don't know if you know, but South Korea is one of those developing countries trying very hard to make themselves known. Okay. So in 2014, before I come to Trichy for 6 months, I was in the Philippines. At that time, they have a hurricane. And after the hurricane, the South Korean sent a lot of money and people to the Philippines to help people. So when we land on the city, everywhere there's banners, Korea help us, Korea help us, okay? Because South Korea is trying very hard to make themselves known because they are at the verge of becoming a developed country, okay? So they have to push, just like China today, okay? China is pushing very hard to make people internationally known for their projects, okay? You may ask, why? Well, because of credit, okay? So if you are a developed country, you will get less money from the World Bank and the EU. I mean, not EU, but United Nations, but you actually become people that contribute money. But that, from a financial perspective, your country actually gets more credit, okay? And more credit means your money becomes stronger and many, many other reasons, okay? And that's why China is in the position, South Korea is in the position, Japan used to be, okay? I mean, they're already in the developed country. But pushing yourself from a developing to a developed level, you have to do a lot of activities, okay? So India may be the next in line to push towards that goal, okay? So, and that is why a lot of those NGOs are actually getting money from those countries, okay? One of my Japanese students worked for the largest construction company in Japan, and she lives in Georgia, and their company is known for building NGO projects in the country Georgia, in other African countries, okay? So this is an area of civil engineering that you may not know because they are not the traditional civil engineer, okay? But maybe one day when you graduate, you may choose to work for a foundation that specializes in NGO projects, okay? Maybe building some bamboo-made homes in Philippines, low-cost buildings that can help people and resist earthquake. So there are many, many of those kind of areas that you can go into, okay? A few years, 2015, we had a conference here, and I invited the Toyama project from Harish. It's the university at Japan, yeah, and their Toyama project is developing PhDs for NGO projects, multidisciplinary, okay, and so many of those things are coming, okay, and you as a student, you should be aware of those. Hiroshima University. Skip, yeah. Okay, and so from a system failure perspective, you're looking for opportunities, okay? And one of the things that I envision that we can improve and reduce failure is that implement failure analysis early on in the project design, okay? Even before you have project development, you should have a safety officer or a failure officer who can look through the history of the development of the project and be able to help correct, identify opportunities of failures so that we can correct those problems early on, okay? And those are more futuristic, but I envision that it will someday be implemented. Just like, I don't know about NITT, but our university, because of promotion of sustainability, we actually has a director for sustainability on campus. So every tree that is being cut down on our campus, the director of sustainability has to approve that that tree is being cut and will not hurt the air quality or the environment quality on campus. Okay, so I think these are the kind of things that we need to do. Even as a civil engineering project. Okay, so something for your thoughts. Okay, and maybe one day as you start your own company, or maybe when you become the head of a project, you can have the authority to designate somebody to do that. Okay, and I think that will help your project to be more responsible. Okay, sustainability and green technology now is a buzzword for any projects, international, national, or local level in the U.S. Okay, so if you want to build a highway, you have to make sure that it's built with local materials as much as you can, and minimize environmental impact to the structure. Okay, and I'm pretty sure in India similar requirements are there for new constructions. Okay, because the world is getting more and more challenging, and we are going to see more of those requirements. Okay, we have to mandate the change. Okay. We have a new student that's arrived. Hi.
Sorry, I'm late.
Oh, no problem. Yeah, welcome. Okay.
So your good name?
My name? I'm Chen. Where's my name? Okay, I'm over there. Okay. Where are you from?
I'm from Mumbai.
Mumbai. Oh, okay. Okay.
Sardar Patel College of Engineering.
Okay. Yeah. Welcome.
You can sit here.
Yeah. It's okay. And so. The classification of system failures, okay, that's another thing that tomorrow when we go through Dr. Shen's lecture notes, we will realize that failures are many different types, okay. So, as you know, structure failure, regulation failure, that's all related, okay. You design not based on design codes, that's a regulatory failure, okay. And then technology failure, if you use the wrong construction techniques and so forth, okay, and believe me, this can be very tricky, okay, and the reason is because we are constantly pushing for more robotics, okay, more automations, and when you have a new machine, there's less of control for the people, okay, and as a result, when you have failures, you have failures, okay, and so how do we make sure that doesn't play into your entire project, and how can you minimize failures becomes a very important aspect, okay? And decision process failure, okay? The flow of information, okay? So in the US now we're pushing very hard on using more BIM, building information technology, management software, okay? So AutoCAD or the Bentley software, they are very popular now, and I'm pretty sure here you are also pushing students to learn Bentley, and you know, well, the flow of data is a big issue. I mean, I personally have difficulty managing my data. Okay, so I've been coming to Trichy for more than 10 times now. This is my 11th trip, and I'm trying to look, even preparing this lecture, I'm trying to find pictures from way back. And I go through so many hard drives, and I couldn't find my pictures, spend hours and hours. So management of data is a big issue, right? But how can we be more successful when we have completely rely on information technology, right? If the electricity is gone in this place, I'm sure nobody can do any work. You know, everybody just go home, right? My kids panic when the power is down and then the Wi-Fi is gone because they cannot play on their iPad, you know, so they'll be yelling and crying, what can I do? You know, technology is gone. So those are really big issues that we have to start talking about, okay? And then behavior, okay? So fundamentally, and there's a school in system and safety engineering that studies behaviors contribute to failure, engineering failures. Okay, so we are all humans. Okay, that is one of the premise in Rybaski's book. Okay, is that we are humans, so we are bound to have failures. So how can we improve engineers so that we can be less failure prone? Is a very big question. Okay, is automation the way to go? Replace all of us? You know, is that the way that we should design engineering for the future? Some people think so. Okay, then what about the rest of us? Okay, how can we protect ourselves or manage ourselves so that in a robotic age that we can work with robots, okay, who makes most of the decisions. Okay, so those are critical questions. And finally, evolution failures. And that is what Robotsky is saying. Because we like to copy one another's work, okay, which, by the way, is not necessarily wrong, but you have to understand how design is done. Okay, every time a new type of bridge coming up, there are people who are so rich, they want you to design one of those. Okay, so how can you find the right information to learn to do the design right becomes extremely important. Okay, and so those kind of evolution failures need to be avoided if we are smart. Okay, and so those are critical questions that we may not be able to address through this class, but you can guarantee somebody is studying this kind of behaviors, okay, or some this kind of problems. Okay, so the role of failure analysis in a nutshell in forensic. Oh, there are more. I don't know how to get. Oh. Okay, well, something missing there. Okay. Oh, sorry. So, as I mentioned, in the Institute of Civil Engineering, there is a proceeding called forensic engineering and engineering safety. So those are the resources that you can go to look up articles or publish your own work. Okay. So this is a paper by Blockley, yep. And here it says engineering safety is best served by forensic science and engineering. Okay, so this is one of the reasons why we should study forensic engineering. Okay, and again, forensic science and forensic engineering are very, very similar, except we serve different disciplines of engineering. Okay, so for civils and mechanicals, we call it the forensic engineering. But for computer science or biomedics areas, they prefer to be called the forensic science people. Okay, and I believe this is okay. Just a few words about forensic engineering in engineering curriculum. Now is 2019. Okay, and in the U.S. we still do not have a BTech in forensic engineering. Okay, and the reason is because in the U.S. and I'm pretty sure India is going towards that. So everything that we develop is dictated by ABET. Okay, so you have to satisfy ABET requirements when you have a certain discipline being established. And so under ABET you have to satisfy all the humanistic, engineering, design, mathematics, the STEM requirements. Okay, and so how can we ensure that forensic engineering BTech certificate has all the requirements becomes a big problem, and the people are still in the community are still debating about this. Okay, and so there are several courses being suggested. In the US today we are still very limited schools that actually teach forensic engineering. Okay, whether it's a one course, 3 credit hours for senior capstone design project, or a 3 hour of a studio type of class, or actually 3 hours of lectures plus homework. There are only a few schools that offer. Okay, I think Princeton or Columbia are the only 2 schools that offers a certificate at the BTech level. Okay, our school has a forensic certificate as a concentration. I think you do concentration as well, right? Structural engineer, graduate BTech, okay, geotech. Yeah, you have to take a few more classes. And so in my school, you have to take 4 classes focused on forensics to get a concentration in forensic engineering. Okay, and many of our students do so. Okay, and these are some of the classes. So there need to be an advanced topic in engineering. That's the University of Taylor as an example. And then Denver, Colorado has a failure analysis and condition assessment class in civil engineering. And then medical device and engineering analysis at Purdue University. And then Purdue also has application in forensic engineering technology. So those are examples of classes that are offered at engineering level. Okay, and other than the technical council that I described under the umbrella of American Society of Civil Engineers, the U.S. National Academy of Forensic Engineering is another branch of forensic science, but they work closely with the lawyers. Okay, and they are the one that mandates a certification to practice in forensic science, and they publish books on how to be a forensic engineer consultant. Okay, and they recognize 4 reasons why forensic curriculum has not been offered in the U.S. So the first one is that it's not a standard discipline. In other words, the traditional discipline is structural engineer, geotechnical engineer, environmental engineer, and transportation engineer. Okay, so any school wanted to go beyond this and create your own discipline, you have to be able to find an equal or collateral discipline so that you can make a comparison. Okay, now over the past we have been looking towards construction management or construction engineering as our parallel. So there are some schools that offers construction engineering as a BTech degree. However, those are not common. Okay, and so you have to look beyond that level. Okay, and the other one is forensic engineering is not a widely known field. Okay, so even in the U.S., many times the lawyers will hire somebody who is a forensic engineer, but that gentleman or that lady may not have any training in forensics background. Okay, as I mentioned, in January I was in a deposition for a lawsuit, and the lawyer from the opposite party asked me the same question. You know, is forensic engineering a real discipline? And I told him, yes, yeah, there are schools that offers this class. Okay, and there are engineers who would have published or qualified in defining forensic engineering. So it is their ignorance. Okay, so we have to educate the lawyers that we are a discipline to be recognized. Okay, and I am also so in the Southeast America, so Americas are divided into different zones. Okay, so I am recognized in the Southeast area as one of the forensic aspects. Okay, so if anyone has a lawsuit, they can look up the catalog and look for engineers in that area and what they practice and so forth. Okay, so if India were to actually implement forensic engineering as a practice in civil, you should have the law association start publishing this kind of catalog, so that all the engineers who qualify or certify or practice should have their names listed under the different areas of expertise. Okay, so those are critical things that needs to be done. Okay, university do not see a need for a full curriculum. That is something that we all recognize not true. Okay, so over the years, the students graduate from my school, about half of them would actually go into forensic. Okay, so you'll be like, wow, how many students you graduate a year? We graduate about 60 students every well, combined probably 90 to 100 students every year, BTech. Okay, and this 100 students, many of them will go into forensic because there are consulting companies that hire forensics, and because those students have trained in forensics, they get picked up quickly. Okay, and the last point is definitely I do not agree. The demand for forensic engineering is not high. I definitely do not disagree, because now forensic engineering is $1 trillion project worldwide. Okay, it's not just in America. Okay, but I will talk about some really high-level, big disasters that require many of us to practice. Okay, and so all of these things we have published a paper in disputing those points. Okay, and the NAFA, the National Academy, also suggests those for MTech level, those are the classes that needs to be involved. Okay, so liability, product liability, introduction to forensic engineering projects, advanced forensic engineering techniques, computer application in forensic engineering are all what they suggest. And computer application in forensic engineering is one area that especially interesting. Okay, and so I don't know how many of you remember the Chennai Malavakkam case. Okay, the faith project that one of the building was collapsed. Okay, so I was part of that investigation, not on the government side. And so the Germans actually did a multi-physics particle mechanics model, and which I will share. And it is a new tool. Okay, and so in the U.S., it is not something that we accept at this point for forensic cases because it's a simulation. And simulation, you have to have parameters that you have to assume. Okay, so there are many things that people will argue. And so this kind of new tools like finite elements, discrete elements are slowly become very popular. People argue, if we use it for design, why shouldn't we use it for investigation? Okay, and so in the U.S. court, this is one of the hot topics, okay, that are being debated. Okay, but we don't have a solution yet, and I will discuss a little bit about those. Okay, and then finally, they highly recommend an engineering ethics class and mathematics, especially statistics. Okay, so as I mentioned, that statistics should be, or that we should study every investigation in a systematic manner. Okay, so some of the cases you can actually build replicates and then study how it fell. Okay, and so those are highly required statistic, but I also argue that this is different from scientific investigation in that you can only have limited data. Okay, and the reason is because they don't pay us well enough as forensic engineer. Okay, in other words, if I were to do a thorough systematic analysis of a certain case, I'll have to do many experiments. Okay, and eliminate all the causes. And I will describe one or two cases in my presentation. Okay, but in chemical analysis, all of us have chemistry, right? In chemical analysis, if you want to prove something has carbonate, what do? You have to have many solutions, right? And then combine, and then suddenly the litmus paper turn blue, you know you have carbonate. That proof you have some solution, right? In forensics, you may not be able to do all that, especially civil, because a beam is collapsed, you cannot rebuild many beams and then start failing, right? So how can we use statistics in a limited sense? Well, that science doesn't exist yet, okay? But people are investigating, and that is called the causality statistics. In other words, it is the statistics that relates to the cause of a problem, okay? And it's a very new area, but it's happening. Okay, so those are the things that we recommend that have a full curriculum. You should have those classes. Okay, these are the electives: safety engineering, human factor in engineering. All these are system topics. Okay, even though they are not directly civil engineer, but they are highly recommended for our discipline. Okay, I think my time is almost. Okay, and so NITT and the UNCC has collaborated, as I mentioned, since 2007. Okay, so I don't remember how many times I have been teaching this. Okay, but in 2010 we have a very special year because we actually get government funding both from India and the US to have a very first international workshop in India on the forensic engineering. And we got funding from multiple sources. It was December 15 to 12. Okay, we had over 200 members participate. And I think this is CN's daughter came up with the name IndusView. And I want to tell you a little bit of history. Okay, so the forensic engineering in India, like I mentioned in the beginning of class, was nothing new. Okay, you have many engineers actually do forensic, but they don't know that it's called forensic until a gentleman called Raika, R.N. Raika. Okay, so Dr. Raika, he's an Indian national, and I think he lives in Mumbai. And I think he's the ACI chapter president at that time. And he and Ken Copper is my ASC, and he's the editor he's the inaugural editor for the Journal of Performance of Constructed Facility, which is this ASC's largest journal for forensic publication. And they are very good friends. And Raika has always been telling Copper, you have to come to India and show us and teach us about forensic. And interestingly, both of them in the same year, I think it was 1984 or 85, they published, not knowing each other, Raika in India on a federal investigation. And then Copper published a similar book in America called by a similar name. Okay, and so they are very good friends. In 2007, before my first trip to NIT Trichy, we actually finally got a first international conference on forensics in Mumbai. Okay, and 10 of us came to that conference, and these are some of my colleagues. And we go to Mumbai, and we visit Mumbai, and we are at the conference. And during the inaugural speech, Raika had a heart attack. He was just speaking, and then suddenly he stopped speaking because he had a heart attack at the moment. And after that, he passed away a week after we left. Okay, and so this is Raika and Copper, the two good friends. And this is a third friend. This is an English gentleman. He's an Institute of Civil Engineer member. Yeah, and they also came here. And then we have the inaugural. This is in Mumbai. And so Raika passed away. But ever since then, and 2007, I come to Trichy, and Dr. Shen hosts me, and he's like, "What did you do in Mumbai?" I'm like, "We're doing forensic engineering." "What is forensic engineering?" I said, "Oh, we do investigation of failed structures." "Oh!" So he drove me all around Tamil Nadu and showed me all these projects that he was involved in, hundreds of them. So many of you may not have the chance to meet Dr. Shen yet. He is a very well-recognized forensic engineer in Tamil Nadu, but he didn't know that what he did was forensic engineering. Okay, and so we become very good friends, and we have a mission. We wanted to do something for forensics, and so 2010 we published the first book on Indo-US forensic practices. There are several articles by 20 plus US and Indian experts in this area. And we come to here, and the library was just built. And this is the setup for the conference. This is my student, Ryan. He also presented some of his work here. And this is my mentor, Dr. Janardanam, at my institute. And he came personally make sure CN and I get the job right. And then all the students at the civil engineering department was involved. Many even before you guys, right? Yeah. And they did this puja every day, a new design. So I thought, oh, this is fascinating. Every day a new design. I really enjoy seeing this. Okay, and over 200 audience sitting there. This is Dr. Delat presenting some of the work, and we have people. Oh, was that you? Yes. And he was a student. Now he's a professor in my institute now. and many of them present. And we also have many Indian experts. This is Prasad from Madras, yeah, and this young girl also from IITS, and these are the engineers from SCRC. So we have many Indian experts. Okay, so it's not like India doesn't know forensic work. Okay, and we have very 200 people, and many of them discuss and talk. This is American, but you know, she dressed in Indian dress. Yeah. Okay, and so many awards and appreciation. So NITT really did an excellent job in showing the hospitality of India, and everybody is still talking about that trip even today. Yeah, this is my chairman. He came with me. He taught one of the longest run forensic class in America, and he retired this year. Okay, so now I'm carry the burden in my institute. And we went to Tanjore. This is a Tanjore, I think Tanjore Temple. Yeah, they love it. Everybody loved it. Yeah. Oh, this was a classic. Everybody was like, oh, that night's moonlight was so beautiful. Yeah, this is our team. This is in Madurai. Yeah. Yep. Uh-huh. So we, after that trip, we published a paper in the Institute of Civil Engineering journal, and basically described the difference between India and U.S. practice. Okay, and so it's really unfair to say that Indian doesn't know forensic engineering. Okay, but the term doesn't carry. Okay, you have a lot of failures. You have a lot of failure analysis. You have a lot of litigations. Okay, but to make it into an actual practice, there are many things that needs to be done. Okay, recognition of domain expertise is one of the area. Okay, so and the other thing is literatures. There need to be a collection of literatures. Okay, and then more importantly, you have to disseminate knowledge. Okay, you have to teach the class. You have to let students learn. Okay, and these are the things that we do a lot in America. And then finally, there need to be a committee that executes recognitions. Okay, I mentioned Babu from Professor Babu from IIS Bangalore. He is pushing really hard for geotech division. I think there just need to be a structural equal efforts. Okay, and then finally, there need to be a national committee in India about forensic engineering. And then forensics is about logic. So one of the lecture that I will be discussing is what is the inverse problem? What makes forensic engineering so challenging? Okay, one of the things you have to recognize is about logic. Okay, one, if A happens and then B happens, does that mean, and then C happens, does that mean because of A, B, it happens C? Not necessarily. Okay, so some of the things I will be discussing throughout this 2 weeks of class is logic. Okay, and one of the things I don't like because it's a very long lecture. So what I suggest is that we make it more interactive. Okay, so anytime stop me and ask questions. Okay, and many of you know me, and with such a small class, we need to be knowing each other intimately. Okay. And then, of course, we will be talking about failure definitions. Okay, so the traditional definition, stress, strain, okay, fatigue, all those are very important terms from a structural perspective. Okay, but then we will discuss some of this carry no meaning. Okay, especially stress. Okay, so I want to put Professor Karthik on the spot. How do you measure stress?
By area.
Yeah, that's the definition of stress, but how do you measure stress in real life?
Real life for the based on the human or structure point?
Structure.
Structure
Yeah.
point.
Mm-hmm. How do we measure stress? You measure load. and then divide by area, right?
Yeah.
Yeah. You measure force.
Yes.
Yeah. What do we use to measure force?
Whatever is applied externally.
The load cell.
Yeah.
Right?
Yeah.
What is a load cell made of? Load cell is actually made of strain gauge.
Yes.
Okay, and then through electronic we measure the voltage change on the strain gauge. Okay, so in reality we're measuring deformation. What is strain gauge? Strain gauge is displacement versus change in length versus change in length, right? So we never measure real stress. Okay, what is strength? How do you define the strength of a material? Yeah, no. That's measure stress. How do you measure strength? When I say a concrete has a strength of 36 KSI or I don't know 56 megapascal, what does it mean? How do you know? No, that's not enough. You take a sample, you fill it, right? So strength is the maximum point when you die. So if I want to ask you how much can you lift, weightlifting, you have to lift until you literally collapse. That's your strength, right? So in a real structure, how do you know the strength? You never know the strength unless you feel it, right? And so many of these definitions carry no meaning for real structures. Okay, and that is one of the challenge. And from a measurement science perspective, we never measure real deformation, we never measure real stress. Because stress cannot be measured directly. The only way to measure stress is by putting strain gauge with a calibrated load cell, right? So the only thing we measure in real life is deformation. Okay, and even deformation is not exact because strain gauge is only this long. You put a strain gauge on a column, you are measuring deformation this much. The rest of the deformations are just assumed. Does that make sense? And we know that the stress distribution is not uniform. So whatever you use for a little strain gauge, the deformation is, we extrapolate our understanding. So measurement science is something that forensic engineers need to know very, very well. And that's why when Navneet is talking about the point cloud analysis, I hope that he projects well enough about our limitation in understanding. Okay, and so in summary, in the context of forensic engineering, failure analysis is one of the core technology that you involve. But failure analysis is multidimensional, and we will be talking a lot about those. Okay, it's not just about something quantifiable, but also something that is qualifiable. Okay, and then it's an inverse problem that we will discuss. And I think those are the problems, the most critical core of this continuation class that started in 2007, that distinguish this series of lectures beyond any other school that teach, is that we actually look at this as an inverse problem, okay, and a logical problem, okay, and that distinguishes us from all the other classes that you would have taken as a BG student. Okay. Okay, so a little bit about what is required. Okay, so because this is sponsored by government grant, and that's why we limit only a few students, because we wanted to get the most out of you, not me. Okay, I just talk. Okay, but we will have one class project, one homework, and then one final exam. Okay, so the class project, we actually wanted to make it like a real investigation. Okay, so you will be given the assignment in class, and then at the end of, I think we'll give you the syllabus agenda for this class. That I think the day before the final, we'll have a final defense. Okay, so you will be divided into groups, and you will do an investigation, and you have to defend your investigation among faculties. Okay, and then we will pretend we're lawyers, and we'll ask you stupid or intelligent questions. Depends on the condition, right? Okay. And then the final exam will be an assessment on how much you learn in this class. And trust me, it will not be easy. Okay, even though it will be only multiple choice problem. Okay, so I think that's the last one. Any questions about this? I think lunchtime. Yep. Okay. Sorry, we run a little bit over time, but every day we'll start from 11 to 1. Okay. And any from housekeeping, any other things we need to let the students know? They are taking care of dinner themselves.
Yeah, they are taking.
Okay.
We will be giving the working lunch to them.
Okay.
In the morning, breakfast and dinner, they will be taking that.
Okay.
So that 2 lectures, whatever you teach, from that they have to understand, and whatever the problem you are giving, let them diagnose that issue. Yeah. Let them present their views before us, and we can give the suggestions.
Okay.
What is the actual?
Yes.
Actual
And also
afternoon hours they can utilize.
So other than the 2 hours of lecture in the afternoon, other than the final defense, maybe you will be most of the time you'll be on your own, and you'll be studying your group. Okay.
The group can be divided when.
Right. We will divide when we give you already give them the project. Okay. So let me explain a little bit about the project. Okay. So you assume you are a consulting company. Okay. And you are asked to go to our civil engineering department. Okay, which is an older building, and then you can go to any rooms, knock on any doors, and then you want to do a building investigation. But I ask you to imagine yourself as a building inspector. Okay, so the requirement is the building safe. Okay, now safe, you have to understand the definition. Okay, I'm not just talking about structural safety. Okay, it can be serviceability. For example, the windows is poorly done. Mosquitoes will come in, and then they'll get nymph disease or whatever. And so those are all critical issues. Okay, so your company needs to come up with your definition of safety. Okay, and we're only asking safety, restricted use, or unsafe. Okay, so if you deem a room unsafe, you have to justify based on your investigation. Okay, and then at the end you give so you cannot do the investigation of the entire building because that's a pretty big building. Okay, but you give as much as you can. Okay, and then at the end you give a assessment of is that building safe for people to work in. Okay, you may say yes, it is only to the left wing, the right wing, or so forth. Okay, and then your group will submit one report, and then prepare a PowerPoint. Okay, and do a 10 minutes of presentation and defense. Okay, so I recommend that you do a 4 minutes presentation. Show as many pictures as possible using PowerPoints, and then conclusion, and then finally how your group is done. Okay, I mean your conclusion, and then we will ask questions. And since everybody is doing the same building, okay, we may come to different conclusions. So you'll be rated based on your group's performance. Okay, and then we'll invite, I don't know who else, whoever has time, maybe the 2 assistant professors, ask them to come. Yeah, ask the assistant. And so, the teachers will evaluate and will rank the groups. Okay, your grade will be based on. No, I'm just kidding. No. You will not be graded for that. Okay, but we will give you rankings. Okay, so which group performed better and so forth. Okay, and so the final report is due on Wednesday 19th evening. Okay, and then I believe the presentation is on the 20th. Okay, so 20th afternoon we will have a get together. And then after lunch, and then you will defend your work. Okay? And how many students we have? So right now we only have.
Everybody are registered.
Yes. Yeah. You're not. Okay.
You haven't registered.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and the other girl, 12. Okay. So, do you more inclined to do 2 groups or 4 groups? We can do 2 groups or 4 groups. 2? Yeah, 2 will be easier. And so you can have more time to do homework. You do the homeworks together as well. Okay? And so 2 groups, projects, and okay, so we'll break the 2 girls up. Okay, so you will be A team. Okay? So we start from you, A, B, A, B, A, B. Okay. A, then B. Okay, so we have the A group and the B group, and the 2 girls are separate. Okay, so 1 girl per group. Okay, and you get to choose your own leader. Okay, one that manages, and then everybody's different responsibilities. Okay, so one will be responsible for summarizing the homework. Okay, and then analysis everybody would do. Okay, because we want you to learn. Okay. And then one will be responsible for summarizing the project report. Okay, and then the group leader make sure everybody do their job. Does that make sense? Okay, good. The homework is actually due 1 day before that because Melanie will go through everybody's process. Can we circulate so we have everybody's email? Can we have one page?
I'll get you the list first.
Oh, and the email too. Yeah, email. Okay, so that we can communicate. Yeah, because there are some data that Navani will have to share with them.
Yeah.
Okay. Yeah. Okay, so that's all we have for today. Where do we go for lunch?
We'll go to the guest house.
Guest house. Okay.
So we have booked the van. So the participants will be taken directly to the guest house, and we will travel together. Okay. Yeah. So that's it for the day's course. We will start with the intro lecture.
Yeah.
And
is there a place where they can work? This room is available.
They can come here, or I can.
How many of you stay on campus? Everybody stay on campus?
On campus.
Okay, good, yeah.
You can, if you want a room, you can go to the MTech structures classroom. My students will be showing. So he is one of my research students.
Okay,
Chandru. He has submitted his thesis.
Okay.
Parthiban.
Yes,
okay, he's waiting for his Variva.
Okay. Variva.
He's also a part want to.
Okay.
Another one student, unfortunately, he got an accident.
Oh,
his
my
leg
goodness.
got cracked slightly. So if he is getting recovered, he may join in tomorrow.
Okay.
So either they will be in A group or B group.
No problem.
So,
Yep.
The group coordination will be good.
Yeah.
So you can diagnose whatever the problem.
Yep.
If you have any structural crack, you can take and you can diagnose why that crack has come. That project is yours.
Yep.
Whatever is that, you take as many as photographs, project your views, and it's just like a training.
Yep.
And the last one, whatever the lectures professor gives, we will be compiling all the lectures, and we will ask some 30 or 25 odd objective questions.
Yeah.
We will just give just 45 minutes or 1 hour test. Some will be brainstorming, as professor said. So please be free to ask any questions in between. So being an introductory class, you all were silent, okay. But the next class onwards, please be very interactive. You can stop at him at any moment. Whatever the doubts and queries you have, you can ask him, and please be free. When you go, I am sure that you should be you knew many things about forensic engineering related to civil engineering. That's it.
Okay.
Now we will disperse for the lunch, and then
make sure your personal belongings are